Hello everyone, welcome back. In this section, we will explore what machine learning really is, how it evolved over time, and why it has become one of the most important technology of the modern world. We will look at how machine learning is being used in our daily lives, often without us even realizing it. From the video recommendation on the YouTube to the navigation system, online shopping, spam filtering, and many other applications, machine learning is quietly working behind the scene. We will also compare how machines learns with how human learns, making it easier to understand the fundamental concept behind this technology. So before we dive into the algorithms, model, and AI system, let's start with a simple question. How does learning actually happens? Imagine a young child seeing a dog for the very first time. The child doesn't know what a dog is. Nobody provided the technical details, definitions such as a dog has four legs, a dog has a tail, and a dog has barking capabilities as well. Instead, the child simply observed. The child sees one dog, then another, then another. Over the time, brain starts recognizing the patterns. It learns that these animals share the similar characteristics, and eventually the child associates those patterns with the word dog. Now, something interesting happens. One day, the child sees a dog it has never seen before. Different color, different size, different breed. Yet the child can still identify it as a dog. The question comes, why? Because the child has learned the underlying pattern rather than memorizing individual examples. Machine learning works in a very similar fashion. Instead of explicitly programming every rule, we provide a computer with many examples. The machine learning analyzes the data, identifies the patterns, build a model based on what it learned. So here you can see these are the examples and machine learns those patterns. And once this model is trained, it can do the prediction. Once trained, it does the predictions, but it does the prediction on the new data it has never seen before. For example, if we show a machine thousands of images labeled as dogs and cats, it gradually learns the pattern and distinguishes them. Eventually, when presented a completely new image, it can predict whether the image contains a dog or a cat. In a simple term, machine learning is a process of teaching computer to learn from data rather than programming every rule manually. Before we understand how machine learning learns, let's clear up a common confusion. People often use the term AI, machine learning, and the deep learning interchangeably, but these are not the same things. Think of them as a layer. Artificial intelligence or AI is a broadest concept. The goal of AI is to build systems that can perform tasks that normally requires human intelligence. So this is going to be on the top. Inside AI, we have a machine learning. Machine learning is a subset of AI where computers learn pattern from the data instead of being explicitly programmed with every rule. Inside machine learning, we have a deep learning. Deep learning uses large neural network inspired by the human brain and is particularly effective for the complex tasks such as image recognition, speech recognition, autonomous driving, and large language model like ChatGPT. In a simple terms, AI is a big umbrella. Machine learning is one way of achieving AI. Deep learning is a specialized branch of machine learning. So when we should use machine learning versus deep learning? That's going to be the next question. Traditional machine learning works well when the data is relatively structured. And the problem is straightforward. Examples include spam detection, customer churn prediction, fraud detection, recommendation systems, and network anomaly detection. And the deep learning is preferred when dealing with the massive data. Highly complex problems such as image classification, speech processing, natural language understanding, generative AI, and autonomous systems. For example, predicting whether a customer may cancel a subscription is typically a machine learning problem. Recognizing a cat in a photo or generating an image from the text is typically an example for the deep learning problem. Now that we understand the relationship between the AI, machine learning, deep learning, let's see how machine learning actually learns from the data. The series is meant for the network engineers. So let's talk about some of the use cases. Imagine a network with 10,000 devices generating millions of logs every day. No human can manually analyze all the data. Machine learning helps by learning normal network behavior, identifying patterns, predicting problems, assisting engineer in operating large-scale network more efficiently. One of the example can be DDoS attack. Let's talk about the DDoS example. Here you see the attackers. Attackers will have access for the compromised systems. Those are called the botnet. And these botnet basically can generate massive amount of traffic over the internet towards the targeted servers. Once the attack is launched, that means all the capacity will be exhausted for these servers and the legitimate users, they will have no longer access for the services provided by this infrastructure. So here you see the normal traffic pattern. This is the normal network behavior. Traffic fluctuates. You can see those up and downs naturally. Small ups, small downs. Those are expected behavior. No unusual spikes. User can access services normally. On the right side, you can see this is an example for the DDoS traffic. The graph shows a sudden massive spike. Traffic remains normal for hours. All of a sudden, traffic explodes. Server resources get exhausted. Users get blocked. This is a problem where machine learning can help predicting DDoS type of attacks. One more example for the network engineer can be the capacity planning. And for capacity planning, you need the historical trends. For example, month 1, 40%, month 2, 55%, month 3 goes to 70%, month 4 is 85%. Machine learning can predict link utilization may exceed 95% within next couple of months. This allows engineers to upgrade bandwidth before user starts experiencing network related issue caused by the network congestion. Let's try to understand how we do the traditional network monitoring. A traditional network monitoring will include collecting the metrics, display those dashboards, generates alarms, and require human analysis. Examples can be you might be monitoring your network with the Nagios, Zabbix, PRTG, Grafana, SolarWinds. They can very well collect all the data. But when it comes to the prediction, it's a human intelligence what is needed, and you have to analyze all the data manually. When it comes to the AI ops capabilities, which is basically the artificial intelligence for the IT operations, the anomaly detection, predictive failures, alert correlation, capacity planning, and the root cause analysis. These are the kind of the capabilities commonly provided by the tools offering the AI ops. So if you talk about the latest monitoring tool, they all are claiming they are AI ops enabled. You can further divide your machine learning capability into three different branches. One is going to be the supervised learning. Another one is unsupervised learning. And the third one is going to be the reinforcement learning. Let's talk about the supervised learning. Supervised learning is a type of the machine learning where we provide the computer with both the input data and the correct labels. Think like a teacher helping a student learn. The student doesn't guess blindly. The teacher shows example and tells the student whether the answer is right or wrong. In supervised learning, the training data is basically labeled. The label is the correct answer provided by the humans. The machine doesn't understand what a dog or the cat is initially. The machine will convert the images into the numbers and mathematically learns which pattern are associated with that particular label. So here if you see a data, this is the training data and every image is basically tagged with a label. Similarly, if you take example of DDoS attack, you can provide similar data. These packets per second should be the threshold. These number of SYN packet rate, the total number of connection count, and the traffic volume. So combining that all metrics, you can put a label whether this is a normal traffic behavior or this can be the DDoS attack. You can further divide your supervised learning into two categories. One is going to be the classification. We talked about detecting the images, whether this is dog or the cat. So output is a category and that is based on the labels. So those falls under the classification basically. Another category is going to be the regression. In the regression, if you're going to predict a numerical value, for example, weather, house price, those are the numbers. So you should ask, am I predicting a number? If the answer is yes, then that learning is going to be the regression. In the next section, we'll go hands-on and I will try to explain you how this regression and the categorization and the classification basically works, and we'll do some hands-on. So I will see you in the next episode. Thank you for watching.